everybody, hi, Mike here, and we're going to continue our discussion of KSP. If you remember where we left off last time, we were going to write the KSP expression for barium phosphate and find X and then solve a problem with it. So let's get back at it, folks. Hope you're doing well. If you remember let's backtrack a little bit. As you write the reaction of it dissolving in water, barium we can represent as 3 plus, 3x, the concentration of that, phosphate plus 2x, and we plug the 3x into the KSP expression and the 2x, we get 3x cubed times 2x squared equals 6.0 times 10 to the minus 39, the value from the chart. Okay, 3x times 3x times 3x is 27x cubed. 2x squared is 4x squared. All that's equal to 6.0 times 10 to the minus 39. And of course 27x cubed times 4x squared is going to be 108 x to the 5th power. So 108 x to the 5th power is 6.0 times 10 to the minus 39. Let's continue that down here, okay? We'll use this eventually. We're going to find X. X is the molar solubility. How many moles per liter of this salt are going to dissolve? All right. 108x to the 5th power is 6.0 times 10 to the minus 39. So let's go ahead and divide both sides by 108. So 6.0 times 10 to the minus 39 divided by 108 equals 5.555 repeating. So X to the 5th power is 5.56 times 10 to the minus 41. How am I going to get X? I'm going to have to do a 1/5 power of both sides. So if I do X to the minus 1/5, X to the 1/5, excuse me, both sides, that would just be X on the left. So what I will do is I've got a Y to the X button. I'll just go and hit Y. 1/5 is 0.2, Y to the X, and I get a value of 8.89 times 10 to the minus 9 units. Came out of a K, that's moles per liter. If you wanted to check yourself or you wreck yourself, you could multiply that by itself 5 times and you would get 5.56 times 10 to the minus 41. If you so cared, you could check yourself by saying 108 times that to the 5th power should give you your K back. All right, let's solve the problem of how many grams of this are going to dissolve in a 55-gallon drum, and I just remembered I forgot my periodic table. Darn. All right, let's use that to, I'm back, by the way. I found my periodic table. It was under my pillow. And so let's go ahead and take X, which I said before is the stem of all the sort of problems you're going to solve. 8.89 times 10 to the minus 9 moles. Now, moles of what? Barium phosphate. That is gonna be back to good old Gen Chem 1 mole barium phosphate, whoops, is real heavy stuff, folks. 601.921 grams. There's our grams, but whoopsie, it was per 1 liter. Now, there is approximately, if I remembered right, there is approximately 3.94 liters is 1 gallon times 55 gallons. All right, so let's go ahead and crank that out. So our answer is 0.00116 grams. That is 1.16. It's just a little bit over a milligram. So that's a thousandth of a gram. A gram is a paper clip. So that's not really much for a big old 55-gallon drum. And that's because KSP is small. But remember, these all don't shake out the same way. KSP sets up different ways. Let's kind of recoup what we talked about here. What the heck did I meant to say? Let's sort of replay all the scenarios. If a salt breaks into 2 ions, it'll set up as an x squared up here. If it breaks into 3 ions, it'll set up as a 4x cubed. If it breaks into 4 ions, it'll set up as a 27x to the 4th power. This guy broke into 5 ions. That was a 3 bariums and 2 phosphates, 108x to the 5th. I think we've seen just about everything you're going to see, folks. Okay, good job. This kind of drones on. So let's go see how my tomato plants are doing. Look at these guys. They're just itching to get out there. And, maybe when the soil temperature... Hey, Mike, what? I was wondering if you could put me in the game, Coach. Put me in the game. I want to get out there. I want to get out there. Well, the soil temperatures are... I don't care. I won't let you down, Coach. Come on, put me in. Put me in the game. How about, like, Saturday when the soil temperatures are a little... Okay, thanks. I won't let you down, I promise. Okay, that tomato plant really needs to sort of reel it in. But if we're going to get some warm weather this weekend, and I'll take a chance on him, but he might regret it. Okay, so here's our next job. The next use of KSP constants is we can predict if something's going to form a precipitate or not. So let's kind of read through the lines of what this problem is saying. We're going to add equal volumes, and by the way, these problems are much easier when they're equal volumes. I think there might be one in your book that ain't, and that's a bummer, but you'll see where I'm going with this. If we have equal volumes of 0.005 molar calcium nitrate and same concentration sodium sulfate, will a precipitate happen? So just real quick, and back to, I know I keep saying Gen Chem 1. This is going to be what we call a precipitation reaction, and so what will happen is, I'll put a little question mark, this make calcium sulfate? And then 2 sodium nitrates. So you remember that there's this is basically net ionic equation, calcium plus sulfate. It's the reverse of the KSP. Forget all the spectators, right? They're just kind of hanging out, being a source of charge. So if we go look, this tells us that that's the insoluble combination. And so if we go find the KSP constant of calcium sulfate, that'd be the reverse. It'd be calcium sulfate solid, dissolving in water. And looking at your table, you guys look along with me if you could, please. Over on the left-hand side of the chart, there's calcium sulfate. This would be KSP, all right, equals concentration of calcium to the 1st power times sulfate to the 1st power. And that, importantly, is a value of 2.4 times 10 to the minus 5. That's the biggest KSP we've seen thus far. So what happens is, when you have a saturated solution, which would be what a precipitate is, that product has to be equal to that number. But what if it was less? Then you wouldn't have a precipitate. So basically, if the number of the concentrations of each of these is less than that number, then you wouldn't even have a point where you've gotten to equilibrium yet. The concentrations are too small. But you can't have a product. It'd be kind of like Kw with water. You can't have this product ever be greater than that number. But it's different than Kw of water, because water's always that product. This could be less. Like, what if that was point 1 times 10 to the minus 6 and 1 times 10 to the minus 6? That would be a combination of 1 times 10 to the minus 12. That'd be way smaller than that. And it would be an unsaturated solution. So we're going to get, when we plug in these numbers from the given problem, we're either going to get a number that's greater than KSP, and that would mean a precipitate, or we're going to get one that's less than KSP, and that would mean that the ions could dissolve to that level. Let's see what happens when we do this. There's one complication, though. Tricky, tricky, tricky. When you add these two together, the volume would double. So the moles per liter of each would not be 0.005. It'd be 0.0025. So let's plug in 0.0025 for each and see what we get. All right, so when you add 0.05 molar calcium nitrate to 0.05 molar sodium sulfate, the volumes would add, and so this would be, we'll call this Q. Right? Remember back when we were testing if something's at equilibrium, we call it Q. You can't call it KSP because we don't know if we're going to be there. So this would be 0.0025 molar times 0.0025 molar. And it's going to be some number either bigger or smaller than KSP. So this would be 6.25 times 10 to the minus 6. Not by a great deal, but by a factor of, like, say 4 or so. That is smaller than KSP. No precipitate. So the KSP is sort of the threshold at which a precipitate would happen, and that's its other use besides figuring out how much of something would dissolve in so much water. Guys, that is it for chapter 15. We are going to go have an exam. There'll be another video on the new material, but no, it won't be covered on the next exam. So this is it, folks. This is where we got to go into review mode, ask questions, and take a peek at that book. It might be good. You're probably itching to move your lives forward, as am I. Bye.